Hey, welcome back. Hope you're all well. Thanks for joining the channel. Good to see you again. Today on the bench I got an AKAI AP-206 turntable. It's brought to me from a client. He wants it serviced. I think this is his daily driver, to be honest, and I think it developed a few problems. Probably the switches and pitch controls need cleaning. He didn't really say, he wasn't specific on if it has any problems. I don't think it does, but I think he mentioned, for one thing, he wants something done with the ground lug on this. Like, it looks pretty, doesn't look very good. I could replace the ground wire with something. We'll check that all over. And we'll check over the whole machine, give it a lube, and see what we can do for it. It's been sitting here a while. I apologize. I got a lot going on my plate right now. We're doing renovations to parts of the house, and the place is an upheaval, and my time is limited, so let's try and get through this. What kind of head shell assembly? It looks just pretty. It looks like a generic head shell. He's got a nice cartridge on there. I don't know what it's, a Grado. I don't know anything about cartridges. I know very little about turntables. All I know is they spin at the right speed and the needle goes in the groove. That's pretty much all I know. But we know how to get them working again. Let's see here. Stylus. I'll have to look at the stylus under the microscope because we'll see what kind of condition that's in. So I'll put this aside for now. It doesn't get damaged. And direct drive turntable. It's a nice little unit. It's heavy. It's very heavy. It's got a nice solid base. Direct drive, auto return. It's got some good features. I like this. I like the controls because you don't have to get up here. You can just do this. Anti-skating. Yes, so we can give this a quick service, give it a test, make sure everything's working. Okay, before I go any farther, let's give it a test because we're dealing with the unknown here. Anybody remember this stuff? I do. Flirting with Disaster. Yeah. I don't even remember what these songs are anymore because it's been so long since I've heard any of this stuff. This is back, dare I say, when I was in high school. Okay, so I got the power amplifier hooked up, and I got my own realistic amp here set on phono. Got a lot of hum, but I don't think the head shell helps that. The missing head shell. Let's put the head shell in. Okay. It's a lot quieter. Let's try the ground screw. Okay. Connecting the ground screw makes all that hum go away. That's what we want. Maximum volume, silent. Okay. Let's try this out. I am plugged in. Is there a power switch I don't know about? It's right there. Okay. So everything sounds like it's working good. Looks like we're doing the correct speed. I never did check the speed. Let's try this. Speed's a little bit off. You can't see it where there is a strobe here, and we can't Yeah, this pot here is messed up. You can't really adjust it. It's twitchy all over the place. Let me move the camera and show you this. Okay. Let's try adjusting this. See how it's not stable? It's losing its lock or whatever is going on there. And I think that's more than just the dirty pot. I think that is, wow, that's really messed up. Okay, all right. Okay, it looks like the motor is accessible from below. There's 2 screws here. I don't know if those are motor screws though. It's hard to tell. No, I don't think they are. Well, what we're going to do is we're going to flip this over, or put the cover back on. Everything's locked down. Remove the platter, and we're going to flip this over and see about removing the bottom. Yeah. What do we got here? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 screws. So I'll remove these. They're an odd size. They're a smaller size Phillips. Okay, is that loose? Yes, okay. I'll get a little magnet here. Collect all these screws. Okay, here's a good look at the underside. It's kind of big, doesn't fit in the frame, but you get a good idea what's going on here. Here's a tone arm with the signal wires coming off of it, going to the signal board before it heads out on the 2 output cables. Power input here, it's unplugged right now, I believe. Yes, it is. It is a 400 milliamp fuse in the primary. Pretty basic. It goes to a transformer, and then we have a little power supply here with a couple of 400 milliamp fuses, 2 more, and then we have our electronics for the motor. The motor itself, the mechanicals are very simple, which is good. Simplicity means reliability. Switch is the power switch here, and that's on the primary side. So, doesn't look like anybody's been here before. The screws are still sealed with Loctite on the motor, and some of these caps here, we can check all these caps out, but we'll see if we get any weak ones. These AKAIs, they build these turntables pretty good. From this era, I like AKAI stuff. It's well built and easy to service too. That's another important thing. So here's down in the bottom corner, got my speed adjust potentiometers and the switch. It's all easily serviceable. We can take this all out and service that. We have a neon lamp here. This is probably lines voltage for the neon lamps. So you gotta be careful there. I think the first step here would be let's service the motor. It's all wire wrapped in. I don't like that. We can cut that. We can cut this tie, and that'll give us some room. That'll give us some room to service the motor. Take this out, service the bearing in it. Okay, let's see what we can do for this thing. So what do we got here? Looks like, oh, it's pretty interesting. I wonder if this comes out. Yes, it does. Okay, so we have bearing on the bottom, bearing on the top, and we have a ball bearing in the bottom. It looks like, I think there's one in there. I can see something. I don't know, this is a brass. So let's relubricate all this. I don't think it's been done since the beginning of time. See if we can get that ball bearing out. There it is. And let's see here. This ball bearing is covered with some kind of a yellow oil. Let's clean that and put it aside. All right. So I was at a place called Princess Auto here in Canada. They sell something like that. It comes from China. It all comes from China. It's probably equivalent to your Harbor Freight in the United States. So you can buy these. I don't know this. I can't remember what I paid for these. It was like $5 or $8 or something. And look at the size of these cotton swabs here. Holy smokes! And they come in all different sizes. So yeah, that was kind of a score. I thought, yeah, why not? Let's try it. Let's try it for electronics. We'll see how it goes. But so here's these ones. I don't think they're going to fit though. They're a little too big. Yeah, they are too big. That's what I thought. But I do have smaller ones. And here's some of the smaller ones. Let's go down. Oh yeah. Just absorb all that old oil. Get down in there and clean it all out. Okay, get another one. Just trying to absorb all the old oil right now before I go in with cleaners. Okay, it's pretty clean down there now. So what I'm going to do is give it a shot of this. Just going to give it a shot of this stuff. Down the... Oops, that's a little too much. Got a little excited there. Okay. Get out the remainder. Just a few more cotton swabs and we should have it cleaned out. There we go. It's nice and clean now. Yeah, it's not bad now. Okay. So that's all clean from all the old grease and oil. Let's clean this. Okay. One more shot of this stuff. There, yeah, looking good. Okay, everything's clean. Now I'm not sure about this cap. It looks like a black plastic cap that's threaded on from the back side of the underside. It's not loose. I'm not going to force it to come off. I think it's just another access point for the bearing. So if we have full access from above, I don't think we need to take this off and disturb whatever is going on in there. I'm not sure what it is. I think there might be a locking pin or something. I'm not sure. Because there is a hole drilled in the side here. I can see something hiding in there. There might be a pin in there locking it. So I'm just going to leave that alone. I don't need to play with that. So what I'm going to use for lubricant is just a synthetic lube, synthetic grease. Just going to put a small amount here for the ball bearing. Put the ball bearing back. Ball bearing's clean. Ooh. And then I'm going to lubricate down. I'm going to lubricate the bottom bearing from here. Get about that much. Let's get some more. Okay, let's see how this thing spins. It should spin free with a light grease. I know people say oil, 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 but I'm not a big fan of oil. I've seen oil disintegrate into goo. Let's give it a little bit there. Give it a little bit here. Okay. Let's reassemble this. Pretty good. Okay. We can reassemble that. Okay, we can reassemble that. Put a couple screws to anchor it while we work on the electronics board. Okay, we got audio. Okay, great. All right, I'm done with this board. I cleaned the back side. What I've done here, I explain to you. If I can flip it over this way, and it can go, actually, it can get mounted back on the standoffs. Pulled a lot of capacitors off, tested them. For the most part, these larger ones here, they're all good. A lot of the smaller ones tested quite a bit off in tolerance and value, so I replaced 6 capacitors. 1, 2, 3, 4, 5, and 6. And that's as far as I'm taking that. It wasn't really necessary to fix them or replace them, but I think the way the age of some of these caps are, I think it's good, because having an out of tolerance capacitor isn't ideal in a circuit. Okay, so that's back together. Our I forgot to wear. Motor is done. Up next, we have our little controls here we have to deal with. So I'll pull these out. I think this one here. Oops, yeah, plastic plate fell off. Okay, let me remove this lamp here. This lamp, just so that the wires won't break when I'm fiddling with it. Okay, neon lamp, looks good. If it was all black inside, you could probably replace this, because over time, with use, the metal comes off the two electrodes and just deposits itself on the inside of the glass, and it darkens the glass. So we got two little controls here and a switch. This kind of annoys me when I see this. You got a switch here with, this is a double pull, double throw, and they're only using one half of the switch. Why wouldn't they use both halves? And then, that would prevent or reduce the it would reduce the chances of poor contacts and connections. So what I plan to do is I'm just going to bridge these six pins here. I'm going to bridge these three together. These three, this one, and this one. I'm going to bridge these together. So we're using both sets of contacts. And then let me check the contact resistance on this thing. It probably needs a good clean. Let me see here. What do we got? I have to get my meter set up for it. Okay. So let's close the switch. I'm getting 13 milliohms, which is pretty good. Let's try this side. That's 11 milliohms. Okay. This side. That's 13 milliohms. 10. And last one. 38 milliohms. Okay, that one's a little dirty. So yes, I'm going to clean this switch, and then I'm going to jumper these wires from these two sides. Actually, I could just do this here. Yeah, I'll jumper them. It'll look more professional if I jumper them. So what I'm going to use is this wire here. This is a wire wrap wire. I think it's a multi-core, but it looks like it's tinned, so I'm just going to use this. I scraped the lugs so that the oxidation doesn't impede the soldering. Let's see if I can get this in. Okay. Let's try soldering this one. Okay. Let's cut this. Problem is I got my wrong glasses on right now and I can't see very good. The other ones, my good ones, are upstairs, and I don't feel like taking the time to go get them. Just fight with my old ones. How come this is not cooperating? There we go. Maybe I was doing it at the wrong angle or something. Okay, let's solder this one. Okay. One more. All right. Right. Now, okay, let's test the contact resistance now that we've. Let's go from here to here. Still 12 ohms. 7.6 milliohms. 15. This one's, I haven't cleaned this switch yet, so I'm going to clean this. But that'll improve. Okay, so I'll clean these pots, clean the switch, and then I'll put it back together again. Okay, let's see if we made any progress with how this thing operates. Okay, we are on 33. It is still twitching all over the place. Wow, it's really bad. Let's try 45. Supposed to be doing the bottom one, and it is all over the place, just like the 33. So it's definitely not controls or the trimmer pots here. There's something going on with that motor. It is really twitchy. Okay. Problem is, I can't get a owner's or service manual right now because the website vinylengine.com is down, or it's not down. It's just their download section is not happy. That definitely needs fixing. Okay. Okay, I'm at quite a bit of a loss here as to why the speed is jumping all over the place, but one thing I'm going to do is I'm going to perform all of the electrical adjustments as per the service manual. There's a few here. There is an offset voltage adjustment, a duty ratio adjustment, a torque difference adjustment, speed adjustment, and then there's a phase lock loop. This is not for this model. This is for the quartz locked model, but this one is not quartz locked. It has no crystal. So I'll go through these adjustments and we'll see if that fixes it up. What I've done is I've actually mounted the board upside down on two of the posts here. Motor is all back together, and I can put the platter on, and it makes it easy for testing, right? Otherwise I'd have to flip the machine over to do my test, and then I'd have to probe from underneath, and no, it's not going to work. So I'm going to go ahead with the first one here, the offset voltage, and it requires me disconnecting all the motor wires and then taking some measurements and setting offset. Okay, for the first adjustment, the first step is remove all the motor wires, and that's what I've done here. I've completely disconnected the motor from the printed circuit board. I don't think it's totally necessary to remove the grounds, but I did it anyway, so it's set in the manual to do it. Another thing I'm doing here is I have the power switch jumpered so that it's always on, depending on the tone arms in the rest position. So to get the turntable to power up, you have to jumper this power. And for our first measurement, we need to connect the DC voltmeter to pins 6 and 8. Let's turn this on. 4, 5, 6 is right here. And 7, 8 is right here. 7, 8. Okay. And then next step is short circuit of pins 9 and 10. So let's short out pins 9 and 10. Another clip lead here. 9 and 10. Okay. Power this on. Going live. And it shows we have about 1 or 2 millivolts. Adjust VR4 until the output at pin 6 is 0 volts. Okay. Plus or minus 10 millivolts. Wow. Well, we're already there, so don't know how much more better we can get that. Let's try adjusting it, which is VR4. VR4 is this one. Just making it worse. Okay, here's 0. Okay, kill the power and open this. Connect the DC voltmeter between pins 7 and 8. Okay, 7 and 8. Short circuit pins 4 and 5. Okay, there's our short circuit. Power on, and then adjust VR5, which is this one here. So the output is pin 7 is 0. Okay, let's see what we got. Let's power this up. Okay, so we got 3 millivolts or so. It's not bad. Okay, there's 0 now. Alright, that's it. Pull the power, and I'll connect up all these motor wires again. Alright, the next adjustment's the doobie cycle. Right here, doobie. No, it's actually duty. They spelt it wrong. So, connect the oscilloscope to test point 1. Test point 1 being up here beside this little chip. Set the speed to 33 1/3. Get the motor going and adjust VR1 until the oscilloscope shows a waveform as shown here in figure 17. We want to get this, not this. Okay, so I got everything set up here and got it up on the scope. Let's get this running. Put power to this, get it up and running, and then I'll put you on the scope and you can see for yourself what kind of a waveform we have. There's our waveform. I'm going to adjust VR1 to try and tweak this. See if we can get this better looking. Turning it counterclockwise makes it worse. Let's turn it clockwise. Oh, that makes it worse too. Okay, I gotta get right in the middle of that sweet spot. It's getting close. Yeah, let me try this. Right there, maybe? Is that look good? Yes, it does. It looks a lot better. Okay, the last adjustment is the torque difference adjustment. And what that entails is you connect a dual channel AC voltmeter to pins 6, 7, and 8. 8 being the ground, 6 and 7 being your two channels. Now, I don't have a dual channel voltmeter. I've never seen one before in my life, so I don't know what they're talking about here. So I did try it with the voltmeters, and it doesn't work because the frequency that's coming out of the for the motor is such a low frequency. It's like 20 hertz or something, and there's no way you can do it with a digital voltmeter. Even with an analog, two analog meters, you can't do it because the needles are going at different phases. But you can do it with a scope, dual channel scope. So set the speed selector to 33 to third position and move the tone arm. Okay, we got the tone arm motor going. And then we adjust VR6 until the outputs of pins 6 and 7 are the same level. Okay, so let's try this. I got my scope on pin 6 and 7. It's looking pretty good. Let's put you up in the scope so you can see what's going on. Okay, I got both channels superimposed on each other, so you only see the one, but if I spin the platter, you can see that they're both there. Okay, and they're out of phase with each other, right? This is a power offs right now. I'm just spinning the motor. So let's take the power cord, plug it in. And let it spin up to speed. Now we need to adjust VR6 so that both of those are at equal amplitude. And the way it is right now, I think the blue one is lower in amplitude, so I'm going to go up on the blue. Turn it clockwise. If I turn it a lot clockwise, this is what happens. It's a huge difference. I'm going to back it off. Now this is kind of tricky. You gotta kind of get these the same. I think it's not bad right there. I think. Is the blue a little low? Oh, I'll give it a little more. I'm looking at the bottom too. And the top. Top and bottom peaks. I have a feeling that's pretty close there. That's all I'm going to leave it at. I'm going to leave it at that. I think it looks good. You see, with every half rotation, the amplitude jumps from one high to low, to high to low, to high to low. I don't know why it's doing that. I don't know if that's a fault. Yeah, I don't know. Okay. I'm going to leave that alone. Consider it done. The only other adjustment we have is a speed adjustment. And let's see here. So the last adjustment, speed adjustment. You set these two potentiometers to their center position, rotation, and then you adjust these two trimmers to get it to lock on the correct speed. So I'll do that. I don't need to do that on camera. Alright, now that I'm finished all the adjustments, I can actually close this up. I think the problem originally was these two trimmer pots, maybe more. They were dirty and they were making a flaky connection, and with me in here tweaking them, it kind of cured itself. But I did deox these two, and I deoxed these two. So I think it's holding steady now. It's not twitchy like it was before. So now I just have to flip the motor over, remove my jumper, and we will close this all up and then we'll flip it over. Just remember these bottom case screws are going into wood. So don't over torque them because you'll strip them out, and then once you strip them out, that's it. So just snug them down lightly and don't force it. Well, there it is. It's finished. I have this all set up. I set up the tone arm for 2 grams like it was before. Test records playing it. It's holding speed. It's working good. So I'm gonna assume this one's complete, unless another problem crops up that I'm not aware of. But it looks like it's ready to go back. So yeah, it's actually a very nice turntable. I really enjoy this. It's a nice performer too. Direct drive. And yeah, don't look at the cover. The cover was provided just for service, so I was able to flip it over and not worry about damaging a nice cover. This is his second cover, but yeah, it's all looking good. Replaced 6 caps in the electronics. Some of these caps are way out of tolerance. And then the blue ones I replaced just because they're Sanyo caps. And they are garbage at this time of their life. So, let's return this back to the owner. I think he's going to be happy with it. I also put a new end on for the ground connection. He wanted me to redo that one because it was all messed up and short. So I lengthened it and put a new speed end on there. So it's all ready to go. Alrighties, thanks for watching, and hope we'll see you in the next one. Take care.